Hey guys, this is the last section in Module 5. We are going to be graphing inequalities, which we've done on number lines before, but we are going to be graphing inequalities on a coordinate grid. So super similar to graphing lines, but inequalities are going to have, instead of y equals mx plus b, it's going to be y is greater than mx plus b, y is less than or equal to, greater than or equal to. So here we're going to use the same exact steps. We're going to start by plotting the y-intercept on the y-axis. We're going to use the slope, rise and run, to get a second point. Then this is where the inequality piece comes in. Instead of just connecting those 2 points, we are either going to have a dotted line or a solid line. So if it is greater than or less than, not or equal to, it's going to be a dotted line. If it's a solid line, that's if I have greater than or equal to or less than or equal to. That's when it's going to be a solid line. Then we are also going to shade one side of the line, either above or below. So greater than or equal to, we're going to shade above. And then if it's less than or equal to, we're going to shade below. And notice we can test a point to make sure that we shaded correctly. So I'll show that to you here in the example. All right. So this has the form y equals mx plus b, but instead of equals, we have less than or equal to. But this is still the y-intercept, and this is still the slope. So my y-intercept is 3. We want to start with that. And my slope is 4, or 4 over 1. So I'm going to go up 4, 1, 2, 3, 4, and over 1. And I'm going to now decide, do I do a dotted line between those or a solid line? So because it's an or equal to, it is solid. Okay, so everything I've done so far is exactly the same, but now here's kind of another different piece that goes with inequalities. I need to shade above or below then the line. So this would be above the line, and this would be below the line. So even when it's slanted, that can be kind of hard to tell. So above the line is when the y's are bigger than the y-intercept. Below the line is when the y's are smaller than the y-intercept. So y is less than or equal to. Less than or equal to, we are shading below the line. So it doesn't have to be super fancy, just kind of something like this. Light and fast shows which side you are shading on. Now the test a point piece that was in our steps. Test a point. So I'm thinking that I shaded correctly. I want to check a point. So I always like to pick zeros if I can, but 0, 0. So that point, should it be in the shaded region? So if it should, my inequality should be true. So the point right there is 0, 0. So I'm testing 0, 0. So I'm going to plug in 0 for x and 0 for y into my inequality. So 0 for y, and I'm asking, is it true? Is it true? I'm checking this. 4 times 0 plus 3. So that's going to stay. 4 times 0 is 0, plus 3 is 3. So is 0 less than or equal to 3? So if it's true, which this one is, I shaded the correct spot. If I pick a point that's in my shaded region and I get something that's not true, I shaded the wrong side. So just another good way to check. All right. Starting with this one, we want to graph the y-intercept, -5. Slope is -1/3, so I'm going to go down and over to get my slope. So down 1, 1, 2, 3 is the run. And this time, I don't have the or equal to, it's just greater than. So this is going to be a dotted line coming through here. So something like that. I still put the arrows on the end, but it's not a solid line. Shade above or below. This is y is greater than, so we are going to shade above. And again, you could test a point. 0, 0 would be another great one to test. So if you plug in 0 for y and 0 for x, we would get a true inequality, so I know that I shaded the correct side. All right, a couple more here. All right, so these ones are not in our usual slope-intercept form. Well, we've dealt with this already. If it's not, we are going to get it in slope-intercept form by getting y by itself. So in this one, I'm going to rewrite it here. I want to get y by itself, so I'm going to get rid of my x's. And just like before, I like to write my x's first, just so I'm used to seeing my slope first. So at -3y is greater than -4x, and that's a +12. divide by -3, divide every single piece by -3. Now, this is an inequality. When I divide by a negative, I have to switch my symbol. Negative divided by negative is positive, but I'm going to leave it as a fraction. And then 12 divided by -3 is -4. So now it's in the form I'm used to seeing. Y-intercept is -4. Slope is positive 4/3, so I'm going to go up 4 and over 3. Okay, and this is going to be a dotted line because it's just less than, not less than or equal to. All right, and I'm going to shade below because y is less than. All right, last one here, you guys. We have kind of the same process here, but I don't have a y. So this should be an indicator that it's actually going to be a vertical line because we only have an x and a number. So I'm going to go ahead and get x by itself here because usually our vertical lines are x equals a number. Is a vertical line, if I could spell vertical there. Okay, so if I subtracted 2 here, I'd be left with x is less than or equal to -2. Okay, so I'm going to graph it as if it were x equals -2, which is the vertical line going through -2. And I still ask myself dotted or solid. This is going to be solid because it's got the org 2, so I'm going to do a vertical line through -2 on the x-axis. And now, instead of shading above or below, we're going to shade left or right. So this is x is less than or equal to -2. So where the x is smaller than -2, well, that's going to be left on the x-axis. So we are going to shade on the left side. So that's kind of a unique one. When we didn't have a y, we're dealing with a vertical line in that situation. All right, so these last couple examples, we are given a graph, and the shading is a little hard to see, guys. I'm going to add to that. So this one is shaded here, and this one is shaded here. Okay, all right, so we are going to write an inequality. So we want slope, y-intercept, and then we need to decide greater than or equal to, less than or equal to, or just greater than or less than for our inequality symbol. Okay, so y-intercept here is -5. My slope, so I'm going to find 2 nice points. So the y-intercept's a really nice point, and then maybe this one's another nice point. So I go a rise of 1, 2, 3, and a run of 2, and it's positive, so it's a positive 3 halves for the slope. Okay, so I have 3 halves. I'm leaving this spot blank for my inequality symbol. Is my slope, and then my y-intercept is -5. So I know that part's good to go. Now I just need to figure out which symbol to use. So it's dotted, so I know it's not an or equal to symbol. And then my graph is shaded above. Anytime it's above the line, it is greater than or equal to. In our case, just greater than, since it is a dotted line. All right, same process on this guy. Y-intercept, right here is 4. Slope, okay, I'm going to find another nice point. That one looks pretty good. So rise here is 3, run is 1. And it's negative because it's going down. So my slope is -3. All right, and write my inequality. So y, leave that spot blank for now. -3 is our slope times x. Y-intercept is +4. All right, so this one has a solid line, so it is going to be an or equal to, and it is shaded above the y-intercept. So this one is also greater than, but it's going to be greater than or equal to. All right, okay, last one here, we are going to tell whether or not these solutions, these points are solutions. So if it is in the shaded region or on a solid line, it is a solution. Now, if this was a dotted line, points on the line are actually not solutions, okay? So that's really good to know. All right, so we're gonna look at this guy. So here, -3 and 1. So -3 up 1, that point is in the shaded region, so this is a solution. 0, 2, so 0 and up 2, it's on the line, but the line is solid, so this one is also a solution, okay? This one we're going to use the equation, so we are just plugging in x and y and seeing if it's true. If it's true, it's a solution. So x is 3, minus y is -1, and I'm asking myself, is that greater than 2? So this is 3 plus 1. 4 is greater than 2, so that one is a solution. 2, 0. So plug in 2 for x minus 0 for y. Is that greater than 2? So 2 minus 2 is 2, or excuse me, 2 minus 0 is 2, but 2 is not greater than 2. This is 2 is equal to 2, it's not greater than 2, so this would be no. Okay, this would be a situation where I'm exactly on a dotted line, and it is not a solution in that case. All right, guys, that is it for graphing inequalities. Thanks for watching.